Okay, let's carry on. This bit, guys, I don't really want to spend much time on it at all, okay? This is something I want you to be aware of, okay? There's a lot more written about it in your textbook, so you guys can always read up more about it if you want to, okay? And this is, once again, I've taken you through a more mathematical approach or a formulaic approach where we had NP equals that one and the contribution margin formula. There is another way of doing CVP analysis, and that's using a graphical approach. Okay, and specifically, there's 3 different graphs that we can use to do this analysis. And those are a break-even chart, a contribution chart, and a profit volume chart. Okay, each of those scenarios that we did early on in the lecture, you can apply using, or get the answers using, one of those 3 charts. Right. I'm not going to go through and do an example, redo all the examples again. Okay, but I just want to quickly flip through this whole idea of these charts and the graphical approach. Just because sometimes it's nice to see things graphically rather than just pure plain numbers. Okay, so what we're saying with the break-even chart is we've got our fixed costs, which is the blue dotted line along here. And with volume, that is going to remain constant. Okay. We then have our total cost line, which initially will start at 60,000 Rand, but then as we start incurring our variable costs, our total costs are going to start increasing, aren't they? Okay. Likewise with our total, let's go back a step there. So the difference between my total costs and my fixed costs is obviously going to be what my total variable costs are. Looking at sales revenue, once again, we're saying under the accountant's model, that's just going to be a linear relationship as our volume increases. So as each ticket sale increases, so our sales revenue will increase by 20 Rand. Okay. Then what we say is we're going to achieve break even at the level where our sales revenue line intersects with our total cost line. Did you guys perhaps have a look at this in economics? I'm not sure whether you did or didn't. You did? Okay, well then I don't really need to labor the point too much. Obviously, to the left of our break-even point is where we're going to be in a loss. To the right, we're going to be in a profit. Okay, so that's just a nice way of saying it, okay? Well, our break-even point over there, that's going to be at a sales volume of 6,000 units or at a sales revenue of 120,000 units. Okay. I've also, one of the things that I also like about this graphical approach is you can actually go and put your relevant range on. You can say, well, for this assumption of total or fixed costs to remain constant, that means I've got to be in the sales volume of between 4,000 tickets and 12,000 tickets. So if I do some analysis and I come out with an example of 13,000 units, well then I know I'm outside of my relevant range. I need to go and reconsider what my fixed costs are going to be, what my total costs, and what my sales revenue is going to be. Okay. Okay. Next thing that we have is, Sam, so you didn't get a proper smoke break.
It wasn't a smoke break.
No, but I'm just thinking you didn't get a smoke break.
I don't need one.
You don't need one. Look where you're at. Okay, if you get major nicotine withdrawals, tell me, all right. Okay, guys, the next chart that we have is what's called a contribution chart. And essentially what we have is it's similar to the break-even chart. We have our sales revenue, we have our total costs, but now we're also going to put in a variable cost line. Okay, because we're talking about contribution, we're not really worried about fixed costs. So we haven't included fixed costs on here, all right. Okay, and essentially what we're saying is obviously the difference between sales revenue and variable costs is going to be what my contribution is. Once again, I can show my break-even point where my sales intersects my total cost. Okay. Last graph that I've got to show you is a profit volume graph. Okay, where we plot a profit line. This graph is showing the impact of volume on our profit. And once again, Break even is going to be where our profit line intersects the 0 line. Okay. And everything to the right is going to be profit, everything to the left is going to be a loss. Okay. So guys, that's very much a graphical approach. As I say, if you're wanting to read up a little bit more about it, do so in your textbook. I'm not going to ask you the graphical approach in your exams. Okay, it's too fiddly. To get you to draw graphs takes up too much time. Technically, I could have said, oh, well, I could give you a graph and ask you to analyze it, but it's just a bit of a nightmare. So I can tell you up front that you're not going to get examined on the graphical approach. Okay, guys, one more example that I want to run through with you quickly. We've got a super bright company which sells 2 types of washing machines. This is now going to illustrate this whole point of common fixed costs. Okay, we've got a company here that's selling 2 types of washing machines, a deluxe model and a standard model. The financial controller has completed the sales forecast for the next period, and we'll get to that in the next slide. Okay. What are we told? We're told that there's some common fixed costs, and they relate to costs of common facilities and can only be avoided if neither of the products are produced. Okay, so for us to avoid those, we've got to say we're shutting down our operations. Okay, our managing director is concerned that our actual sales may be less than the forecast and has requested information relating to the break-even point for our activities for the period. So let's go and have a look at this information that we've been given. Okay, we've been given some sales volume in units for our deluxe and our standard. We have what our selling prices are. We have our unit contribution, total sales revenue, total fixed costs, our contribution. We then have our avoidable fixed costs, direct avoidable fixed costs. So these are fixed costs that are directly related to the deluxe model and directly related to the standard model. I.e., if we didn't produce the standard model, we would avoid fixed costs of 27,000. Okay. We then have another line item which is our common fixed costs, and that's what we were told in the previous slide relate to both of these machines. Okay, we stop producing the standard, we're still going to incur 39,000. We stop producing the deluxe, we're still going to get the incur the 39,000 overheads. Okay, so this is a complexity that we now have, is we have more than one product and we have some fixed costs that relate to more than one product. So the whole question arises, how do we treat these fixed costs? What do we do with them? And there's potentially 3 different options, as you'll notice in your notes, okay? One is we can simply ignore them. Do you think that's a good idea? So I mean, you're shaking your head quite vehemently. Why would you say no? Why can't we just ignore them? Anybody help her out? Shame she's looking. And why can't we just ignore them? What is break even? It's where we make neither a profit nor a loss. If we ignore these fixed costs when working out our break even point, are we going to make a profit or a loss? We'll make or we could quite easily make a loss if we only sold our break even units. So we'd be thinking, oh, we've broken even, when in actual fact we made a 39,000 Rand loss. So we don't really want to just ignore them. The other option would be to say, okay, well, why don't we just allocate them to those products or services? Right. So there we say we'll take the 39,000 and we'll split them up between the deluxe and the standard. That's also a little bit problematic. We'll know that we'll end up covering them because we've included them. The problem is, how are we going to allocate these fixed costs? It's going to be a totally arbitrary allocation. And we know from decision-making point of view, it's not really nice having to deal with arbitrary cost allocations. Okay, they fudge our decision-making. So the third alternative is, well, why don't we use a sales mix? And essentially what we're doing there is we're using a sales mix to allocate these common fixed costs to the products or services. Okay. So that's what we're now doing. Guys, are you comfortable with what I mean by sales mix? Okay. So how many products, how many of the standard machines do we sell in relation to the number of deluxe? For every one deluxe, how many standard machines do we sell? Okay. So the first thing we're going to go and have a look at is say, okay, well, what is our sales units? What's our total contribution? Okay. We now know that our sales mix, it's going to be 1,200 divided by 600 units. So I'm basing my sales mix on my number of units. So for every one standard machine we sell, we expect to sell 2 deluxe. Okay. What we're aiming at achieving here is we're saying, okay, we've got this problem of fixed costs. So what we're going to do is we're going to do break even based on a sales mix of 2 to 1. And essentially what we're doing there is we're now going to say, right, that gives us the opportunity to calculate a break even based on a 2 to 1 sales mix. That's going to be a break even of a number of batches. And what's a batch going to be made up of? It's our sales mix of 2 deluxe to 1 standard. Okay, so we can now say, okay, well, what is our contribution per unit? Okay, it's 150 and 90 Rand. Okay, you can see where we get our contribution per unit from. Okay, 180,000 for the deluxe divided by our sales of 1.2 million. And likewise for the standard, 54,000 divided by 600. So if we're wanting to have a break even per batch, and each batch has 2 units of deluxe and 1 of the standard, we now wanting to say, what is our contribution per batch? That's going to be 2 contributions from deluxe, i.e. our 2 times by 150, and we're only going to have contribution from 1 standard. All right, so our contribution per batch is going to be 390 Rand. Okay, so now we're no longer working on 2 separate products. We're working on 1 type of batch based on the sales mix. Okay, we can now say, right, let's go and work out what our break even is for these batches. Once again, we know it's going to be our fixed cost divided by our contribution, not per unit in this case, but contribution per batch. Okay. So there we go. What's our total fixed cost? Well, our total avoidable fixed costs are 117,000. Guys, you happy where that comes from? Maybe just flick back a few slides and make sure that you can see where that comes from. Okay. Directly avoidable fixed costs. Okay. Plus the 39,000, which is our common fixed costs, divided by 390. That tells us that we need to break even, we need to sell 400 batches. Okay, what we now need to do is go and convert those 400 batches back into units of deluxe and standard washing machines. Okay, and you'll remember that each batch contained 2 deluxe and 1 standard. Therefore, our break even is going to be 800 deluxe washing machines, which is my 400 times by 2, and 400 standard washing machines. Okay, so that is what my break even is going to be. How have I dealt with the common fixed costs? Well, I've said this combine everything into 1 batch. We create the batch based on our sales mix, and we can go ahead and calculate our break even. Okay. Guys, this is just a continuation from the other example, and I'm wanting to use this to illustrate what some of the problems are of CVP analysis, one of the limitations, particularly where you have more than 1 product. Okay, sorry. It's the same as example 2, except that the actual sales for the period was 600 deluxe and 600 standard machines. Okay, remember what we said our break even was? It was 800 of this deluxe, 400 of the standard, giving us a total of 1,200 washing machines that we need to sell. Guys, in this example now we say, okay, we sold a total of 1,200 machines. Okay, there's still been 1,200 customers who've wanted to buy a washing machine from us. What is the problem is we haven't sold 800 deluxe. We've only sold 600. Okay, so you can now see immediately that's going to have an impact on our profit and loss, isn't it? Because we're expecting to sell 800 to break even, and the deluxe has a higher contribution per unit than the standard, we are actually going to end up with a loss, even though we've sold the total break-even number of units. Okay, a bit of dwaying on our face, isn't it? Okay, let's just quickly go and say there, right, well, we've got our sales units of 600 each. Our unit contribution was 150 and 90. Multiplying that out, we're going to get a total contribution of 90,000, which is 600 times by 150, 600 times by 90. Okay, so we've got a total contribution of 144,000. We've got direct fixed costs of 117,000. Okay, and we've got common fixed costs of 39,000, resulting in a net loss of 12,000 Rand. Okay, so guys, one of the limitations or one of the assumptions that you got to be able to make when you're using CVP analysis, where you have more than one product, is that you can assume a constant sales mix. So in doing our break-even analysis based on our budgets, we assumed a sales mix of 2 to 1. If that cannot be, our break-even analysis is only going to work if that sales mix is actually held to be true. Okay, very, very difficult in practice to predict what the actual sales mix is going to be. Okay, so there are a little bit of a warning bells that should be going off there. Okay, guys, questions? Good. Okay. Guys, these are some of the CVP assumptions. Some of them are more obvious than others. They are discussed in your textbook to some extent. I don't want to bore you going through them too much. Okay. These are them. Some of them we've mentioned already, relates to the short term. Okay. There we go. The single product exists or a constant sales mix can be predicted. Those we've dealt with. Okay. Other ones that we indirectly dealt with is the things that total costs and revenue are linear functions of output, i.e. we're assuming the accountant's model holds, not the economist's model. How do we make that assumption more valid? Is by working within a relevant range over which we can expect this assumption to remain true. Okay. Guys, also another important one that we haven't directly touched on is that profits are calculated on a variable costing basis. What did we say variable costing profits were? Remember we looked at that at the end of cost allocation. We said it was our revenue minus our variable costs minus our fixed costs. Remember, in working out what our inventory balances were, we excluded all fixed costs from our inventory. Okay. So what we're saying is one of the problems with absorption costing is that it fudges what our true economic profit is. Because what it does, it takes some of the fixed costs that we've incurred for the period and includes them in closing inventory. It defers them into another period. Okay, so CVP is saying, because we're working on the basis of contribution, we're wanting profits to be calculated on a variable costing basis. However, we can get around that if we calculate them on an absorption basis, but the number of units produced equals the number of units sold. That means that there is a net zero deferral of fixed overheads. Okay. I think quite an obvious one is that we should be able to accurately split costs between fixed and variable costs. Okay. Guys, there are quite a lot of assumptions with this. There are some limitations. Okay. I still think this tool has a place. Okay, it is useful to be able to calculate things like break-even and marginal safety. I think from a practical point of view, the thing you guys must just be aware of is that these limitations do exist, and just to question the kind of answers you're getting to make sure that it is valid for you to use. Okay. And guys, so that is cost volume profit analysis. That is the end of my kind of formal lecture for the course, and you're supposed to go, oh, yeah, that's it.